Vanador present in this virtual meet by the joint efforts of ACIDE, a Center for Incubation and Development of Entrepreneurship, and Industries Institution Interaction Cell of the Standard Fire of AXEL College for Women, Sivakasi, an international webinar on education for industry is 4 and the digital future is going to come in. The thing well begun is half done. Let us start this webinar with a prayer song. Please close your eyes for a while to invoke the blessings of Lord Almighty. Hara Hara Shankara Om Om Shubhara Shankara Om Namami Shiva Paramesha Bhajami Hara Vishesha Mangalam Sarvesha Shubha Mangalam Jagadisha Shubha Mangalam Jagadisha. You can open your eyes as well as your ears fully. Sincerely was a welcome address. Let me call upon Dr. C. Rajamani, the coordinator of ACIDE. Rajamani?
Good afternoon all. This is a glorious moment to extend my warm welcome on behalf of the Center for Innovation and Development of Entrepreneurship and Industry Institution Interaction Cell of the Standard Fire Rajarudram College for Women, Sivakasi, to the international webinar on Education for Industry 4.0 and the Digital Future. First of all, I take great pride in welcoming Mr. AXEL Angeli, Digital Future Evangelist, Director, Locosburg, Germany. Thank you, sir, for accepting our invitation. We are all very much anxious to know about the development in digital technology and how it is going to create revolutionary changes in the industry from your speech. Our warm welcome to our respected principal, Dr. T. Palaneshwari, who is a backbone in all our endeavors. We also welcome Mr. George, IIIC Business Solutions, who play a vital role in organizing this webinar. We welcome all the participants from our own institution as well as from various institutions and industries to this webinar. Finally, I would like to express my heartfelt gratitude to my teammates whose sincerity, dedication, and commitment make this event as a successful one. Once again, I welcome one and all present here. Thank you.
Thank you, ma'am. Now, I am very happy to welcome the special guest, Mr. George Abraham, the Managing Director of IIIC Business Solutions, Bangalore. Sir is an innovative, technical, entrepreneurial, strategy-driven management professional as well as consultant in the Indian IT world to do research on artificial intelligence, robotics, cloud, ERP audits, and many. By the sincere efforts of him only, we were able to organize this international webinar. Thank you, sir. And he is the right person to introduce the chief guest with us. Now, I request him to introduce the chief guest. Please, sir.
Thank you for Sivakasi Fireworks Rajarudram College to give this opportunity for me and AXEL. To introduce AXEL in little words is very difficult for me because I worked with AXEL for last 7 years. So AXEL Angeli is the most wanted person in different countries for the government, for the MNC companies, and he is a very good solution architect and advisor. So he is a very busy man. He connected with India through IndiaSoft. IndiaSoft is an organization where Ministry of Information and Technology, Ministry of so he represents Germany for the IndiaSoft Expo, and as well as he helped India to collaborate with Germany, Indian government to collaborate with Germany. Likewise, he is doing for different countries also. And he is a founder of Logos World, and he is a good author of SAP. His books are SAP Press approved one, and I hope people who know the SAP know the SAP Press. So he is a SAP Press author too. So, some books like SAP R3 EDA and Interface, SAP IDOCS. These are all his major books which in the market right now. So he used to evangelize the technology in all over the countries and for the major companies also. And he's a good consultant, and he's one of my good best friend also. He is very much interested in encouraging the students. So because as he is in a busy schedule, even when I called, he was accepted to come and connect with us in this meeting. He's a very busy guy and traveling more, and he knows better than us in India. So he is from the top to bottom. We may know about the South India or nearby wherever we went, but he knows the entire India. He's look like a German, and he knows everything about India. So let's welcome AXEL Angeli. AXEL, the screen is yours. You can continue with your presentations.
So thank you very much. Namaskar, vanakkam to everybody and it is really a pleasure for having me to present this webinar for you. As you all already said, the webinar will be about a buzzword which is known Industries 4.0. There are other words for this, artificial intelligence for industries and smart industries, connected industries, woven industries. Industries 4.0 is currently the most popular buzzword, and it means simply how we can use the modern technology in the future way how we work all together. So this presentation will now give you a little introduction on artificial intelligence, how it is used in Industries 4.0, and then I will do a larger excursus how this impacts the way how we learn in future, because this is a presentation for a college, and colleges should be interested in actually not only hearing what is out there in the world, but anyway to understand how this should be transported to the students and how should we learn in future using the technology that we are teaching. Okay, I have to switch it a little bit slow. Okay, so in terms of artificial intelligence, you're not seeing the presentation right now, but wait, you have to see the presentation soon. Before I start, you see here in the background of myself, probably the castle, the famous castle of Heidelberg. If it looks a little bit like the Amber Fort in Jaipur, this is not a coincidence. The design model of both castles is relatively the same, like Jaipur is also very much designed the same way as my hometown Mannheim. And what you see here, I'm not sitting in front of this castle. I'm sitting at home in the background. This is what artificial intelligence already does. It takes the background away, it detects my face, and it replaces the background with some arbitrary picture. So if I want to change the picture, you see? So I think it takes a little bit of some seconds for you until you see it, but I think by now you should see an elephant behind me. So now I'm in the African savannah with an elephant that is behind me. And now I'm switching to the presentation. You could see my presentation also with my face in front of it. You see, now with Paris in the background. So what I'm going to tell you here is, you see a lot of artificial intelligence already the moment I present this presentation. But now the question is actually, how would our life look like if you would not have artificial intelligence in our daily experience? Look at the search engines. Google. Google is artificial intelligence poor. They recognize what you want and they find information exactly the way how you would imagine, how it fits your interests. So if two people are asking, are you still having my picture? Because I see here some error message on the window, on the Google.
Yes, sir. Yes, sir. We can view it.
You see my presentation. It's good?
Yes. Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Okay. Okay. Then we look at navigation systems like the Google Maps or the TomTom system or all Garmin systems. These are all artificial intelligence. They find the route exactly according to the traffic that just happened. So if you look at Google Maps, it shows you immediately which roads are blocked due to a traffic jam and what would be the more intelligent way to go to be faster at the endpoint. Smartphones, they are fully packed with artificial intelligence. You use your fingerprint to open the smartphone. It can recognize your voice and your face. And voice recognition, Alexa, has become very popular. This is artificial intelligence because it does not only recognize your voice, it also recognizes your voice. So if somebody else says something, it can make the difference that your voice and the voice of somebody else are different. And both technology is now used often already in access control. So if you want to go into a protected room, then you show your face and you have to say a word, and your voice is so unique like a fingerprint so that the computer can detect together with your face and the voice that it's really you and not somebody else. This is safer than having just a badge that you show to somebody. But then we have artificial intelligence also in these platform economies like Uber. Uber is not just a booking site where you can book a car. No, it intelligently matches the request with the availability of certain cars. So this is also artificial intelligence behind, and Amazon would not exist without artificial intelligence. Okay, there's some animation there. And then we have something what is now called robot process automation, RPA. I think many of you might have heard about this because this is currently a trend. And this means that they do a lot of activities that humans would have done before. You call a hotline, you say, okay, I have to reset my password. But before, the robot would have forwarded you to a proficient clerk and a proficient executive who made the change for you. But now the robot knows you want a new password and it does it without any human intervention. So this is artificial intelligence as we have it today. So artificial intelligence will change the future, and it will also help us to cope with the future. I will give a little bit example on COVID-19 later, because there already artificial intelligence is very helpful in containing the virus in the world. And artificial intelligence, it's not a name for human-like machines. So this is a warning in the beginning. The AI, it emulates a human intellect, and it helps performing complex, time-consuming tasks better and faster. But it does not simulate a human brain. Artificial intelligence is widely dumb machines. So artificial intelligence uses the power of the machine to do things faster. And it does it with higher precision. Like, we know it from number crunching. That is where the way the computer comes from, to compute things faster and better. And we know it from doing systematic analysis of loads of data, because our computer is simply much, much faster to go through a database with millions of records. A human would take years, a computer takes seconds to analyze this. So this is where the computers are strong. But they are not strong when it comes to doing smart things like our humans do. So I say artificial intelligence is dumb technology. Keep this always in mind. It is a machine that does things, and it does the things better because the machine is usually faster and it can get data from places where others have difficulties to gather the data from. And this situation will remain for quite some long time. So, because AI still does not know culture, it does not know creativity. AI does not relate to anything what we humans call feelings. So all the wonders you hear about artificial intelligence are based on the exponentially growing speed of computers. And because we have now so many data available that is collected by devices around there. So if you see the picture of the famous Sophia here behind in the background, you see the lady here, this is the Sophia robot, and in some shows it is very popular to show this lady because it can answer questions and it somehow behaves like a child or like a pet. But intelligent is something different than what Sophia is presenting. During the COVID-19 pandemic, we used a lot of artificial intelligence in the form of what is called machine learning. Machine learning is basically mathematics, and because we have now so many data from everywhere in the world, the machines can analyze all this data and they can try to find similarities and differences from the data that is found in different places in the world. So they can compare the data from Europe with the USA and the USA data with India. But they can also compare the data collected from cities in India with the rural areas in India. And from these differences that we find in these clusters, we can make derivations and we can give a good diagnosis analysis how the virus might spread. You might have heard about the Johns Hopkins University. The Johns Hopkins University has become famous during the COVID pandemic because they have specialized in collecting data from all over the internet and putting them in their own database to make derivations. So they applied machine learning and data collection and published them with the interest to give more and better information on the COVID-19. Artificial intelligence is now also present in agriculture. So a lot of fields in where you have high performance agriculture, you have these drones, but you have also little robots who do the job of a seed drill. You have combine harvesters who can actually eventually pack the fruits that they are harvesting, and they know exactly at which moment of time they should pick the fruits and whether the weather conditions are good. And there is so many things that needs to be coordinated, and that what artificial intelligence today is already used in agriculture. So, I said artificial is dumb, but how does it work then? Well, we have basically three forms of artificial intelligence. We have the knowledge-based expert systems. This is a very old thing that existed in the 1980s already, and this is big databases where a lot of information is stored, and then the computer takes the question and he tries to find answers that fit to the question. This is an algorithmic mathematical exercise with a lot of probability calculations, but it's a relatively simple way of building artificial intelligence. So a typical use of an expert system is a medical expert system. So you would present yourself with coughing and with some fever and with having some other symptoms. And now, with the symptoms that you give, the expert system will calculate the likelihood whether you're infected by the coronavirus or not. Another artificial intelligence technology is the machine-assisted learning. That is machine learning, most people say, but it's not correct. Correct, it's machine-assisted learning, because it's not the machine that learns. It is the machine that helps us humans to learn from data. So it's mostly mathematics, as I already mentioned it. And then we have the neuronal networks. They try to simulate the way how human brains think. So machine-assisted learning, they go there, they take a lot of data. They use good old mathematical stochastics to calculate data and make analysis. They try to find patterns with mathematics, and then they make forecasts. So here on the picture to the left, you see the different areas of artificial intelligence, but you see on the upper left the curve with the dots. So the dots, this is the sample data that is found somehow, and if I know how the things are happening in the first quarter of the data, and I can see, okay, there's a certain trend in the curve, then I can continue to extrapolate the curve, and then I make the prediction simply by calculating the further continuation of the curve. So the neural network is a system that emulates the way how human brains associate information. And in order to understand what a neural network is that our brain does not work the same way as our von Neumann computer does. A von Neumann computer, we have a CPU and we have a storage. The storage is cells. They store the data in bits and in bytes. But the brain does not store data in cells. The brain stores the data mostly by the way how the cells are connected with each other. So the neurons, that are the brain cells, they are connected with each other, and the connections between the cells, they build something what we call a neural network, and this association is a pattern, and these patterns describe information. So the brain basically stores data in pictures. The way how the cells are connected make a picture, and these pictures are stored. And if now there are two kinds of cells. Some act as sensors and others act as actuators. They are able to trigger an action. If now a sensor is activated from anywhere, it immediately triggers the actuator and the action is triggered. That is a completely different way from the sequential way how we usually program, and we make use of this different design of storing and storing and processing information. And that is what is called a neural network. And a typical neural network is Google. So now you have seen probably a lot of movies, Hollywood and Bollywood, and when they speak about artificial intelligence, they mean something different. They want to build humans, android people. So when Hollywood says artificial intelligence, they think of what the professions called singularity. That is the moment when the machine will be more intelligent and smarter than a human being or a living mammal. But that is fiction. This happens in the movies. This is not something that is going to happen in the near future. And it's also not going to happen because the interest in the industry for having such things is very, very low. This is a toy. This is not something that is helpful in the industry as of now. While machine learning and neural networks, they are very, very helpful, as you know. Who can live without Google, and who can find his way to your grandmother without Google Maps? So, let's go to the next part. How does this artificial intelligence impact the way how we work in future? We have learned that it is already part of our daily life, but how will it change? The industry calls these changes that is going to happen now in the profession, they call it industrial revolution. And it's called Industrial Revolution 4.0 because they say this is the fourth time we have an industrial revolution. Whether the picture is correct or not, we can see, but they think of having the steam engine, the electricity as the next one, then the mass manufacturing as a revolution, and now the communication revolution with the internet. That is the fourth time that the industry is going to change completely. And when we speak about industries, I always have to remind you, industry is not only making cars and manufacturing. This is the simple form of doing industry, manufacturing. So Make in India is also just give us the simple works and they do them. There is smarter industries, and healthcare is an industry, agriculture, as you already have seen, is an industry. Mobility and logistics, transporting the goods, what Amazon does, bringing the next day delivery, also in rural areas. This is smart logistics, this is an industry. But building smart cities is an industry. Smart energy, so the way how you save energy and use energy in an optimal way, that is an industry its own. Building infrastructure industry, and there's one important part, and that is the last one, the smart science and education. So even education is an industry. So we need to think of education in an industry, and then we can apply the ideas of Industries 4.0 education. Other words for smart industries are connected industries, because it means that all the industries in the world are connected with each other. And we have also the woven economy word, actually, because all the industries in the world are tied together. So, just type in. Sorry for the little break. Okay.
Okay.
Give me 1 second, because I see there's a little problem in this presentation.
Okay, sir.
1 minute. So in the meanwhile, you can see the dogs.
Yes, sir.
Yes, not sure if they are hungry already. Only 10 seconds more, and I think it will work. If you do a lot of video conferencing like I do, I have a very, very fast and very, very powerful computer here, but the power is still very, very limited when you want to use it during a presentation. The PowerPoint loading takes a couple of more minutes than you are normally used to. even if I have a very, very expensive high-speed computer. So, do you see the picture again?
Yes, sir. Industrial Revolution.
Yeah, okay, that is good. So, I just have to get the Google also back. Okay, so, we're here. So, I want to give you now a quick introduction, actually, how Industries 4.0, what the idea behind is. Is it coming? Yeah. Okay. So, what is Industries 4.0? Well, I will try to explain this on the simple example of manufacturing, and let's have a look on an automaker. An automaker today does not build a car completely on its own. Actually, an automaker has a lot of suppliers, and the suppliers, they are producing the components for them. So there is a supplier that might build the motor, there's a supplier that is building the chassis, there is a supplier that can deliver the tires, this is probably a rubber maker, you have a supplier for bumpers, for the interior, and for the dashboards, and for many, many other components that are built into the car. Also in the picture there is the customers. And there are different kind of customers. There are the private individual customers, but there are also corporate customers. Once they decided to buy a car, they will go to the dealer, and there are wholesale dealers, that is for the corporates mainly. There are free dealers, they are for the private people. There are used car dealers. There are spare part dealers, and there are also garages, the ones who repair your car in case of a defect. Now let's have a look on the side of the automaker. What happens there? The automaker, he has a design department. It has a construction department, and of course the assembly line, and it has a testing department that do these famous crash tests with the crash test dummies, and they have a quality assurance department. There are other players here. There are the forwarders, the ones who transport the goods, the cars, and the supply parts from one place to another, and there are authorities who control that everything is done perfectly, all right. So, that is a picture of Industry 4.0, and now, because everybody has a computer, all this industry is connected with each other. That was too fast. So you see here, they exchange information permanently. And now, because they're exchanging information permanently, we can use this data to make analysis, to make better decisions. So, over the internet, we have a lot of data sources. These data sources are the ERP systems of the different companies who work together. So the automaker, the supplier, the dealers, they all have ERP systems like SAP, BAN, Dynamics, Oracle, but also think of a lot of open source systems like Odoo or Trison or ERP5. And India has, I think, 10,000 ERP systems on the market as well. So they all give the same kind of information. And then we have manufacturing execution systems. They are the construction line controllers, they are the warehouse robots, and they are also the shipment organizers. And all this data is also collected from these millions of microelectronic devices, what we in the end call IoT or Internet of Things. And then we have data lakes. The internet itself has a lot of data available. So we are not only relying on the data that is collected from our partners and that we have stored in our own systems. No, we also go as Industry 4.0 partners, we go to the internet, we Google, so to say, data from the internet, and we are going to fish data from the data lakes. Most data lakes are open, So freely accessible, like the Google ones. And a lot of data comes from colleges and universities and academies, like the Johns Hopkins University. This data is free available, and the government is supposed to supply us with a lot of data for free of charge. If you just think Google Maps, if you think that Google has collected all this mapping data to build Google Maps, then you're mistaken. The data comes from the US government. Explicitly, it comes from the CIA and from NASA, because they make the cartography, they make the pictures, and all the data is publicly available in the United States to everybody. And that is what Google has taken, made an interface on top of it, and built Google Maps. There are, of course, also data traders, classical data traders. You know them, Facebook, Twitter. They all go there, and LinkedIn, they all go there and sell the data that they have collected. WhatsApp. And then we take artificial intelligence to analyze all the data that is collected. And this IoT combined with artificial intelligence, that is what we call Industries 4.0. And it can be done in manufacturing, in agriculture, in healthcare, in logistics, education, and more. So this is a short introduction into what Industries 4.0, the idea behind is. And this has an impact now to our industries. We will have connected, woven industries, and the future enterprise, that will be kind of virtual enterprise. That will be not a company who has an office somewhere and employs people. No, a company will probably have 20, 50, 100 people, but they all work maybe from home or from their offices or from the shop floor or from the place where they have to be to do the best performance for their task. So the enterprise itself will be virtual, it will be happen in the internet. And that is what we are going to prepare for. That is what we are going to learn for the future. How shall we do a virtual enterprise, how we build a virtual enterprise, and what is it what we have to learn. The same thing happens in agriculture. The farmer will do his job, but all the machines, the tractors and the harvesters, they are all connected to the Internet of Things, because they all will have little computers, and the data is transmitted to a satellite, and the satellite is sending it across the world with the Internet, where it is taken by some artificial intelligence software to make predictions. They merge it with the data from weather, merge data how pests have developed. A typical example for agriculture 4.0 is how to avoid too much fertilizers or too much pesticides on the ground. So if there is a pest, like you say, you have too many snails on the field, then the farmer might use some pesticide and chase the snails away. But if you Google for it, what is the best method to take snails away, then it says, okay, bring in some ducks. So you will bring in some ducks, the ducks will eat the snails will be gone, the ducks will be happy, and you have an organic farming done. So in future, the computers will not have somebody not ask the farmer has to Google for it. The computer will already say too many snails, and it tries to get this information directly from the internet. So you can say the computer will Google in future. That is what we call Industries 4.0. So now we come to actually the main element. How does all these changes in the world impact our education? There is a couple of studies how Industries 4.0 will change our world. We will definitely see 50% of today's jobs to disappear. Many new professions will be created instead of it. So no panic. 50% will go, 75% jobs will come. So in the end, we will have more jobs than before, but the jobs will be different. So people who are just picking plants from the fields will probably less needed, but software engineers will definitely be very high in demand. At the same time, a lot of modern industry brands will lose their value. So companies that are still very popular today might disappear tomorrow, next year, or in 2 years, just because they have not made the changes needed to adopt to the future. So the prediction is that 3 out of 4 stock-listed firms will be replaced by modern, intelligent, smart enterprises, and they all will renew the business model. Typical business renewal is Uber. So they have changed completely the way how taxi driving works all over the world. So this kind of platform economy is what we will see in future. And we will have to understand that 1/3 of our labor time in future will be spent on education. And only good education will bring many new jobs. So if you are not willing to learn all of your life, you will come to a standstill and you will be probably one of the losers of the next generation. But those who learn, who have learned how to learn, they will be the winners. No. No. Not coming. So, I have a picture here that shows the professions that are needed today, just now. And all of those professions, we have a shortage. We need telecommunication engineers. Especially in the Western world, there are hardly anybody who can do this. We need network engineers. We need mechatronics. Mechatronics people, these are people who can program, but can also use mechanic tools to build the small devices, mechanical devices with electronics built in. The Internet of Things is currently soaking all the available skills from the market. We need skills in cybersecurity, in cyber safety, blockchain. Everybody has heard about blockchain. I can bet that out of 1,000 students, not only 2 really know what blockchain is and can make use of it. So we need people who can understand blockchain, who can use it, and can also make the difference between sense and nonsense. So design thinking, cyber marketing, big data analytics, communication, deep learning, robotics. There is so many things. You can read it later. There is a lot of these kind of jobs are needed. We also need lawyers and justice people who understand technology. If today you go to a court, it is and you have a difficult problem, a sophisticated problem related to IT, it is very unlikely that the judge understands what you're talking about. So we need specialists also in there. The same is for your politics. Your chief minister probably is very, very little informed about the latest information. Even if it's an IT professional, he will probably know what 5 years before was modern. So we next picture, sorry, there is an animation here. Oh, I have to click a lot of things. Sorry for the delay. Computer is very slow. delay, some technical problem.
Okay, sir.
My CPU is on 100%. Okay, now it goes too fast. Now we are in fast forward mode. So, okay, we are back. So, just see this little picture here. Actually, you don't have to look at the details here. It is just the overview picture of the topics that have to be taught to learn Industries 4.0. You can see that there is so much to learn. So, education is future, or the future. Oh, it should read actually, or the future is education. And with the technology of today, we should learn the skills of the future. And because we have given this speech now to India, in the people-rich countries, like in India, also in Africa, investment in education is the way how these countries can be the leaders in future. So they can, because the Western world is sleeping when it comes to education. There is anyway a lot of old people, while in India and in Africa there is a lot of young people, and these old people, they are not willing to learn the next technology. So the first world is sleeping, and Germany, like all European countries, have no ideas about future education. So this is your chance. USA has left everything to the private sector. They are selling their students. They are not educating them. So this is the chance for you. Again, it's going slow. So future education, how will it look like? Well, it will be mainly teamwork. You will have students, you will have mentors, you will have teachers, and the teacher will be on-site, but the teacher will also be remote. And all they can work together in one room, like we do a webinar now. We can have a virtual classroom, a virtual university in the future. So, since I come from Germany and I always hear that everybody admires German quality, the question is, why is Germany so famous for quality? That is related to the education system, because the German education system that is based on the old guild system, they are based on a high degree of standards. So a lot of the things that a baker learns is the same thing that a computer engineer will learn. And because we have these high common standards in learning, that is why we are able to communicate with much less effort between each other, and mistakes are made to a lesser degree. So standards is the secret, and that is what, now it's fallen away. Sorry. Okay, here it's back. So, what do we have to do? We have to build standards. So we have to agree what to learn. We are going to open 24 hours, 7 days training. So all the training material must be available in the internet. So a student who is not here for the show should be able to see the lecture just later in the night. Like we will do with this webinar, it will be available on YouTube later. So those who missed it, they can see it on YouTube. But in order to provide all this material, we need also publishing experts. making a video, making even a presentation like I do, that takes a lot of work. So if some say, okay, yeah, this presentation looks lousy, I would say it looks lousy because from a design perspective, it is really at the beginning, but that is because it takes a lot of time to make a professional presentation, to make a professional video. Even if you want to make just a small YouTube video or a TalkTalk video, you know how difficult it is and how much time it takes to practice until it's finished. But in the end, we will end in something what is called gamification. Learning will be a computer game. The computer will be on one side, you on the other side, and you will just interact with the computer like you interact with a computer game like an ego shooter or a simulation game. But in order to make games, we need film producers. The concept that is behind this new kind of learning is based on what is called flipped classrooms. You know how you learn today. Today, you say tomorrow is Saturday, but okay, this afternoon at 6 o'clock there is a lecture on mathematics. Now you go there and you hear what the professor has to say about math. But in future, you will go to the internet, you learn all the essential things, what should be presented in the lecture, and then you go to the university and then you discuss with the professors the things that you haven't understood or where you have doubts. So you will first deep dive into the internet to learn, and then you go to the college and deepen it. So that is the concept that is called flipped classroom, and that is a basis there. So this gamification is also meant to keep the students more interested in the online courses. If you're binge watching TV and look at the 3-hour sequel of Hobbit, the people can stay concentrated because it's entertaining. So if you ask the Bollywood people, they know how to make good training videos, and if it's entertaining, the people will learn. So gamification is the key for the future. And and gamification will build also teaching material on software that interacts with the students. So as I said before already, it will be a kind of adventure game. Sorry again for a little bit delay. The computer gets slower and slower after a while. Probably he says, okay, I'm running out of time, so I should finish. So I will skip this. Once I said the words before already. This is just a text that belongs to what I have said. And there is one important thing when we use artificial intelligence in learning. The artificial intelligence will not only present you teaching material, it will also learn from your answers. So if you made a mistake, and if 10 students make the same mistake, the artificial intelligence will see if they can improve the way how they present a topic, or to put the focus more on a certain element. Excuse me. So AI instructors will learn from students, from teachers. AI will learn from other internet sources. They can Google, and they can exchange information with other AI software, so AI can learn from AI. That is what the future will be. So now my last recommendation, actually, how should you continue learning? First of all, you have to work together. Students and teachers, you will be a leader in unity. If you work together and build a future while you learn, you will learn better, and you will do something for the future. And you have to give up, of course, your old-fashioned classroom training. You will mostly learn in groups. The groups can be virtual and physical. That is one of the benefits of the COVID-19 pandemic, is that we learn to now to work virtual, not to be physically together all the time. Of course, physical presence is always needed, but there's a lot of things that can be done in the virtual classroom as well. You have to do a lot of hackathons. A hackathon is somebody gives you a challenge. For example, find out what is the best video presentation system for our university, and then 50 students or 100 students come together, give in their ideas, and then they discuss together which ideas should be continued in order to produce suggestions and realize something. The idea behind is to build solutions, not theory. And there is a lot of things that need to be done. And since we only can see a short distance ahead, we will not see what springs the futures, but the opportunities are unlimited. But what we know is that we have to build a learning infrastructure for the future. So this is a little advice to the colleges, how to set up a future-oriented infrastructure. So the first task for building an infrastructure for new learning is do not buy software. Make it together. Students and teachers go to the open source, take what the open source is giving you and improve the software. Not install it and then use it. Don't be a consumer, be a player. Don't watch cricket, play cricket. It's the same for teaching. The open source has so many things. Everything what you need for teaching is there on the open source. And you have to take your students to make studies, to find out which could be the best one, to make tests, build prototypes, and then implement it for your university. The only thing which you should not do not buy it. Have to do by building infrastructure. So the academy of the future is like old academies, and old academies became famous because they publish. They get known because they are not consuming, because they invent something. They research and they publish what they did. So do not simply educate the people to get them a job, educate the people to be able to play an important role in the future. And there is a lot of professions that probably your college and most other colleges do not have already available. You're somehow an arts college, so maybe you have authors and illustrators and scripters and game designers. But most technology colleges, they do not have this kind of people. But these kind of people need to be present and work with the engineers to build the future. They will build the animation videos, they will build the games, but they will also make the software that they design much better. So, you need a vision to be successful. I gave you some ideas for the vision. Don't copy everything what I say. The world is very, very big. India is very, very big. So I gave you one idea here, and it's up to you, to the 1,000 students that you have, to bring them together and collect the ideas. Do hackathons on ideas, do hackathons on software deployment. So this is just what you probably will need. You need meeting software, you need a chat room, where, like a Telegram, but WhatsApp, but for your campus. You need project collaboration software. Slack has become very famous now, but it costs a lot of money. Rocket Chat would be a free software. And I use a lot OBS. This is a software that can record videos, where you can manipulate videos. That is where you can make these little clips, and it's open source. And you need also provide ways how your students can access data. So here is an example of some open source technology that I am using, that I am recommending. So I need video recording software like the OBS Studio. I need video editing software. This is OpenShot. I need classroom conferencing software. This is the bigbluebutton.org. Big Blue Button does the same what the Google Meet does now. But you can install it on your campus, use it on your campus, and you enhance it exactly the way how you need it. So, in the end, you need to be the change that you want to see in the world. Think of great Mahatma Gandhi. So, that was the very end of my presentation. Already thank you. There is one little thing I want to mention before I forget it. I'm offering something what is called Red Books. Red Book is a concept where a university works together with me on a research topic. Usually we go in there for 6 weeks, we work together, exchange information, and in the end we publish the results, what we did. So if you have an interesting research topic or interested in doing such things, I have a lot of topics that we could do. We should discuss about this. Probably there will be 50 students together. I will come eventually, and we do a blended virtual on-present workshops, and in the end we will write a book and a YouTube video and any kind of publication that is needed for the future, so that we can do blended learning with this one. So thank you very much for listening to me, and keep it in mind, you need to be the change. I can only give you ideas.
Thank you very much, sir, for your informative session. Thank you, sir. Participants, if you have any queries, you can post it in the chat box. And we have 2 questions to you, sir, from the YouTube link. Shall I, sir? The first question is neuron networks similar of human neuron?
A neural network tries to simulate the way how information processes takes place in the brain. This is different from the way how any computer in the world today is working. Because computer of today, they're a calculation system. There are huge pocket calculators. A neural network stores information differently, and because it stores it differently, it finds the data very, very quickly, the relevant ones. So it is different because a neural network is not a biological. Yes? You said something?
Sir, some disturbance in your...
Hello?
No, sir. Sorry.
voice.
Say again? I didn't understand you.
No, you can proceed.
Yeah, okay, fine.
Sorry.
So what I said actually. So a neural network is different from a human neural network, because the computers today are still built on silicon, they are not biological computers. If we are going to build biological computers, then we'll build neural network directly in the computer architecture. But that is something that is not going to happen in the next 10 years.
Thank you, sir. Sir, another question, sir. Another participant has asked.
Excuse me, sir. Good afternoon, sir.
Can I play the video, sir?
Yes.
You shared with us that YouTube video. Shall I play the video, sir?
Oh, on artificial intelligence?
Yes, sir. Yes, sir.
Oh yes, okay. We have an extra bonus video actually on artificial intelligence. This is a YouTube video. Yeah, play it. This comes from a professor in USA, an Indian one, and
Yes,
he
sir.
describes very well what artificial intelligence is. Start it.
Yes, sir. Thank you, sir.
Artificial intelligence for people in a hurry. The easiest way to think about artificial intelligence is in the context of a human. After all, humans are the most intelligent creatures we know of. AI is a broad branch of computer science. The goal of AI is to create systems that can function intelligently and independently. Humans can speak and listen to communicate through language. This is the field of speech recognition. Much of speech recognition is statistically based, hence it's called statistical learning. Humans can write and read text in a language. This is the field of NLP, or natural language processing. Humans can see with their eyes and process what they see. This is the field of computer vision. Computer vision falls under the symbolic way for computers to process information. Recently, there's been another way, which I'll come to later. Humans recognize the scene around them through their eyes, which create images of that world. This field of image processing, which even though is not directly related to AI, is required for computer vision. Humans can understand their environment and move around fluidly. This is the field of robotics. Humans have the ability to see patterns, such as grouping of like objects. This is the field of pattern recognition. Machines are even better at pattern recognition because they can use more data and dimensions of data. This is the field of machine learning. Now let's talk about the human brain. The human brain is a network of neurons, and we use these to learn things. If we can replicate the structure and the function of the human brain, we might be able to get cognitive capabilities in machines. This is the field of neural networks. If these networks are more complex and deeper, and we use those to learn complex things, that is the field of deep learning. There are different types of deep learning in machines, which are essentially different techniques to replicate what the human brain does. If we get the network to scan images from left to right, top to bottom, it's a convolution neural network. A CNN is used to recognize objects in a scene. This is how computer vision fits in, and object recognition is accomplished through AI. Humans can remember the past, like what you had for dinner last night. Well, at least most of you. We can get a neural network to remember a limited past. This is a recurrent neural network. As you see, there are two ways AI works. One is symbolic based and another is data based. For the data-based side, called machine learning, we need to feed the machine lots of data before it can learn. For example, if you had lots of data for sales versus advertising spend, you can plot that data to see some kind of a pattern. If the machine can learn this pattern, then it can make predictions based on what it has learned. While 1 or 2 or even 3 dimensions is easy for humans to understand and learn, machines can learn in many more dimensions, like even hundreds or thousands. That's why machines can look at lots of high-dimensional data and determine patterns. Once it learns these patterns, it can make predictions that humans can't even come close to. We can use all these machine learning techniques to do one of two things, gamification or prediction. As an example, when you use what else, then you are classifying that customer. If you use data to predict if they're likely to defect to a competitor, then you're making a prediction. There's another way to think about learning algorithms used for AI. If you train an algorithm with data that also contains the answer, then it's called supervised learning. For example, when you train a machine to recognize your friends by name, you'll need to identify them for the computer. If you train an algorithm with data where you want the machine to figure out the patterns, then it's unsupervised learning. For example, you might want to feed the data about celestial objects in the universe and expect the machine to come up with patterns in that data by itself. If you give any algorithm a goal and expect the machine, through trial and error, to achieve that goal, then it's called reinforcement learning. A robot's attempt to climb over the wall until it succeeds is an example of that. So there you go. Thanks for watching, and if you like my videos, please subscribe.
What is 3?
Sir, we have few more questions to be asked, sir, by the
Yes,
participants.
please, sir. I'm ready.
Yes. Thank you. So, one of the participants has asked about the accuracy rate of the diagnosis of disease report given by artificial intelligence.
Accuracy is
Yes.
depends very much on the quality of the data you put in and the algorithms you use. If you have a lot of data from a lot of different sources, accuracy extremely high. That has nothing to do with the artificial intelligence itself. This is a corollary from mathematics. So if the law of big numbers of Bernoulli that tells us that if you just have enough data, the accuracy will be high enough to make a nearly perfect prediction of the future. So as long as you have a lot of data and the data comes from independent, different sources, the accuracy will be high. So algorithm plays a role, but the algorithm is lesser important than the quantity of data and the independency of the data that you put into the algorithm. Thank you.
Thank you, sir. Thank you. One more question, sir. In Germany, do the students go for industries, for internships, or on-the-job training?
Yes, they do, and they put an additional concept. And in Germany, we have a concept that is called dual studies. In Germany, it is very common that a student, when he starts to study, goes to an employer, asks, "Are you willing to employ me?" And then the employer is paying for the education under the condition that, of course, the student, after he finishes study, will stay for 5 or 10 years with the same company. So there is not only internships is normal, work for industry is normal, but you also have the opportunity to ask a company to pay for your studies. So they give you the stipend. So you work 50% of your time in the company like a real employee, and at the same time, the other 50% you go to the university and learn the theory. This is the old concept of vocational training in Germany. It is called dual study, and it has been introduced in some places in India as well. If you go to the German legacy companies like the Bosch or the Siemens in India, they are also offering similar kind of studies for Indian students and Indian talents. Thank you.
Thank you, sir. Thank you.
Any more questions? The interested participants can give your feedback also.
Yeah. Please do so. And if there are more questions coming, and I know the questions will come probably overnight, or maybe if you see the YouTube video once again, collect these questions and just email me the collected questions, and I will try to answer them as much as my time allows.
Okay, sir.
Okay.
Okay, sir. We will send the questions to your mail.
Then I say Nandri, Dhanyawada. And I hope that we are going to meet again, maybe in person, soon, after the COVID crisis is over.
Yes.
I'm very positive that I will be back in November in India again. I'm very, very positive that the epidemic will develop in our favor, in our interest. And then we can see if we can find a way to meet each other. Thank you very much for inviting me. Thank you very much for having me. It was a pleasure, and I was always surprised that so many people are participating. Thank you.
Sir.
Time. We are at the end of the webinar. I invite Dr. S. Shailaja, EVS Coordinator, to propose the vote of thanks.
Ma'am, am I audible?
Yeah.
Yes,
Yeah,
ma'am.
you are.
Yes. Honorable Chief Sir, AXEL Angeli, our beloved principal, our most valued person, Mr. George Abraham, ladies and gentlemen. It's my privilege to have been asked to propose a vote of thanks on this occasion. Today I take this opportunity to put all my gratitude into words. On behalf of the entire organizing team, I would like to thank the Honorable Resource Person, Mr. AXEL Angeli, for taking his precious time out and consenting to deliver a lecture on Education for Industries 4.0 and Digital Future. I particularly liked Mr. AXEL Angeli's speech, which made us understand the need of digitalization, and the way he explained the subject was extraordinary. Thank you, sir. We are fortunate to be assisted by Mr. George Abraham, Managing Director, IIIC Business Solutions, who graced us with his presence. Thank you, sir. Next, I put on record my sincere thanks to our management members and our principal, Dr. T. Palnisheri, for their constant support and encouragement. My deep sense of gratitude now goes to our participants who are the faculty members and students of our college and various other colleges. Thank you one and all for your cooperation. Thank you.
Thank you. Thank you.
Sir, sir,
Yeah.
by your speech today, 350 participants get benefited by this webinar, sir.
Wonderful.
Okay,
So
sir.
YouTube
Thank you,
viewers
sir.
and Google Meet.
As well as Google Meet. Yes, sir.
Yeah, combined together.
Okay, thank you very much. You have a good weekend, and as I said, I hope to see you all in the real life soon.
Okay, sir.
Thank you very much.
Okay, sir. Thank you, sir. Thank you, sir.
Yeah.
Thank you, sir.
Bye.
Thank you, sir.
Okay, I will also leave. Thank you very much.
Thank you, sir. Thank you for your arrangement.